Yep, so my name's Craig Dolan. I'm the chair of the Heat Pump Association. The Heat Pump Association in the UK is the dedicated voice of the heat pump sector. And our mission is to drive widespread deployment of heat pump technology throughout the UK. Our membership includes the country's leading manufacturers of heat pumps, component parts and associated equipment, as well as energy companies, certification bodies, installation businesses, training providers, wholesalers and distributors. We currently represent over 100 organisations working within the heat pump sector, and manufacturing members represent about 90% of our, representing around 90% of the volume of heat pumps sold in the UK are all our members. So today I was planning to give an overview on a very light touch on how a heat pump works, some myths, why we're focusing on heat pumps, and the challenges and opportunities that we've got in front of us. So forgive me if you all know this, and I know I am very aware that I'm who I'm presenting to, and there's probably quite a few engineers in the room, so apologies for teaching you to suck eggs. So a heat pump is very, very simple. So you collect energy from the air or ground. It's generally solar energy that boils the refrigerant. The then boiled gaseous refrigerant goes to a compressor, number 2, where it's squeezed. Think bicycle pump and your thumb over the top. You pump the bicycle pump, your thumb gets hot. You now have very hot, high pressure refrigerant gas, which is passed through a condenser, which is generally a plate to plate. So you've got high temperature, high pressure gas on one side and water on the other. Hot goes to cold and it's transferred into the heating circuit. The then used refrigerant, which is still high pressure, transfers into a expansion valve. Think an aerosol can. The pressure gets released, turns into a substance called slush, or it's still gas depending on the pressures involved, and then it goes around and the cycle starts all over again. So all heat pumps work predominantly the same way. And if you were to put that in reverse, that would be an air conditioning unit. So, you know, they are prevalent in the UK, very, very reliable technology. We're just using them in a slightly different application. So now on to some of the myths. Heat pumps don't work when it's cold. This has got to be one of the favourite things that gets shouted at to me quite regularly. Of course they work when it's cold. Do we really believe that manufacturers such as Vaillant, Baxi, Ideal, Bosch, Mitsubishi, Daikin, Grant, Panasonic and Samsung have all developed a heating product that doesn't work when it's cold?
I think you're hearing us, I can't get round.
Oh, somebody talking in the background there. Hi, Keith. So this may come from the test point that was used in the past, which was Air 7 Water 35. So that was used as the naming convention for most heat pumps. Now at Air 7, there's no defrost cycle, and at Water 35, if you were on a weather compensated circuit running at a reasonable heat curve, Water 35 would be the temperature of going through your underfloor or your radiators. So that's why that was used. And then in some of the older units, you had something called a drop-off, which was a 7 kilowatt unit might actually be a 6 or a 6.5 at air -3. Now, that's been got rid of now because a lot of people with the newer heat pumps, which have moved into new refrigerant, which I'll get onto later, are now using the test point of air -7 Water 35. So we're delivering the heat when you expect it. Okay, so this is another example of the heat pumps not working in the cold. You can see that in Europe's coldest countries, in Finland and Norway, we've actually got a higher penetration of heat pumps in those countries than we have in some of the warmer countries. There's something relating to this that I'll come to later, but there is another very, very good reason for this. And, you'll see that as we move forward. Heat pumps only work in modern, well-insulated homes. No, heat pumps could heat an old barn with all its doors open if you really wanted it to. It wouldn't be very efficient, but it could do it. They work in all homes. The question is around system design and installation. So it's designing the heating system, be it a boiler or a heat pump, and the heat generator is designed for the peak heating requirement. And the emitter circuit is designed for the correct flow temperature and delta T. The lower the flow temperature, the higher the efficiency. All heating systems, including fossil fuel boilers, will work better in well-insulated houses because the heat load is lower. So the lower the heat load, the better it is for any heating system. We in the UK are struggling a little bit because we haven't moved forward on our heating systems as much as we should have. When we moved from non-condensing boilers to condensing boilers, really we should have lowered the flow temperatures of our heating circuits, but we didn't have to, so we didn't. So now we're in a situation where we've got heating systems that are designed at high flow temperatures, and we've got to change the heat generator and the heating emitters to run on lower flow temperatures. Heat pumps are expensive to run. This is one of the core challenges, but installation costs of a heat pump may be higher than that of a traditional heating system due to the system upgrades that are required. So you are required to update your emitter circuit so it can run at a lower peak flow temperature than that of a traditional boiler systems. But heat pumps can provide 3 to 4 times the amount of energy than they consume, significantly reducing energy bills over time. Additionally, many UK suppliers are now providing, as long as you've got a smart meter, are providing heat pump tariffs which give you lower electricity for your heat pump, which make them much more expensive, much more cheaper to run than gas traditional fossil fuel boilers. Heat pumps cannot provide hot water. This is another one that I get told quite regularly. Heat pumps can provide hot water. Some of the old heat pumps that ran on R410A could only heat hot water to around 58 degrees. But the newer heat pumps running on R32 and R290 can easily provide over 60-degree hot water into your tank. Realistically, at the point of use, anything over 40 degrees or 43 degrees to be precise will start to cause scalding. So you generally on a shower, you have the water at 38 degrees. There is some protection that's needed around Legionella, so you're not building that up. But a weekly Legionella cycle where you purge the cylinder and heat it to 60 degrees or above for a while will eliminate the Legionella bacteria, and storing the tank at 55 degrees or above will kill Legionella over a longer period of time. It's just the amount of time. There are also a range of heat pump hot water cylinders available on the market. These are now standalone tanks with a built-in heat pump on the top that's ducted to the outside, and they are a complete standalone solution for hot water. So you set the temperature that you want, and the heat pump will run and maintain the hot water temperature within that tank as a completely standalone solution, which is probably more familiar to anybody who's spent any time in Central America. Heat pumps are noisy. We get this quite a lot. So modern heat pumps are much quieter than their older units and traditional air conditioning units. It's one of the areas of key market competition where the manufacturers are trying to outdo each other to have the quietest possible unit on the market. Excuse me. The units are often quieter than a standard refrigerator now. The sound power and the sound pressure levels are very low at all frequencies. It is something that has been a real keen focus for all the manufacturers. UK data is now showing complaints about heat pumps are very low, and there are only around 100 complaints for every 300,000 installations when it comes to noise. So a rate of 0.03. And just from some personal experience of visiting a site where they had a noise complaint, the owner of this current house, of this house that I'm talking about, liked to see when their heat pump was running, so they tied ribbons to the front so they could see the ribbons flapping in the wind. Their neighbour spotted this, and every time they saw the ribbons flapping, they'd complain that they could hear the heat pump. I actually went to site and the heat pump was off, and I just turned the fan on, and then the neighbour complained that he could hear the heat pump running when we had the noise assessor there, and it wasn't actually running. So we removed the ribbons, and lo and behold, the neighbour could no longer hear the heat pump. But you know, that's just one anecdotal story. But to get in front of that, with the Heat Pump Association are currently working with the University of Salford to get some active readings from a new build site in the north, where 33 homes all have a heat pump, and we're setting up independent sound measuring equipment in the gardens and in and around the new build estate to assess what noise level are actually coming. So no, heat pumps are not noisy. There is another myth that I haven't included, but another myth that heat pumps don't work with microbore plumbing, which was very popular in the 80s and 90s because it was cheap. So microbore plumbing is the copper piping under your floor or in your walls or in your ceiling that transfers the water around the heating circuit. Mitsubishi have just released a paper today, in fact, a white paper showing some testing that they've done on a number of different housing types with a heat pump and microbore piping. So that's another myth that's just been busted, and we have the paper to back it up, should anybody be interested. Oh, too far. So why the focus on heat pumps? So this graph shows the reduction in carbon emissions needed to meet our legally binding net zero commitment as set out by the CCC. 28 million homes will need to be using low carbon heating systems by 2050 in order to achieve net zero, of which 80% have been identified by the government as being suitable for a hydronic heat pump system. Yet currently, annual heat pump sales represent 3% of the annual boiler sales in the UK, and 85% of properties connected to the natural gas main network. When heating accounts for 37% of the UK carbon emissions, 17% in buildings and 14% in domestic homes, it becomes apparent that we need to decarbonise. The decarbonisation of heat is a key focus for the area of the government, and it is a difficult one to crack. The government are focusing on decarbonising heat through electrification, and there is no doubt that the heating of future will be renewable, electrified, and digitally, and the heat pump electrified and digital, and the heat pumps will play a key role due to their high proven efficiencies, scalability, and readiness to deploy. The previous government had repeatedly set out an ambition to install at least 600,000 heat pumps per year by 2028. And this is the number needed to meet the UK's carbon targets. We're yet to hear how the Labour government are going to do it, but some of the noises that they're making are quite encouraging. Another point to remember is, you know, we all signed up to the Paris Agreement, and what that actually means in reality is it means no new fossil fuel boilers to be installed from 2035. So 2034 is going to be the best year of boiler sales ever. But, 2035 is not that far away. It's 11 years, well, 10 years away, really, seeing where we are in the year. So we've got a long way to go in quite a short period of time. So what are the top 3 challenges to increasing heat pump deployment in the UK? UK homes and the heating system, reducing the electricity and gas price differential, sometimes referred to as the spark gap, and boilers. They do a great job. Why should people bother changing? We need to as an industry, step up to these questions and work with people in government and with the market to make this shift. So UK homes, we have some of the oldest and most diverse and smallest properties in Europe. It simply cannot be one size fits all. We really need a range of systems, products and solutions to work for all of our homes. And this is where we are moving towards. So where we are. We don't know the typical heat loss of a UK home. No one has collected the data. So when you go on an installation journey of having a heat pump installed in your home, you have to have a room by room heat loss calculation completed. When you get a new boiler fitted in your home, you do not have to have a heat loss calculation fitted. So we have never collected the data on how much heat our homes require to stay warm and comfortable. We know from the sales data that boilers are massively oversized. So a 30 kilowatt combi is sized for the hot water load and not the heating load. And even a 14 kilowatt system boiler is, generally speaking, largely oversized for the majority of properties that it's in. Our heating systems are set up for high flow temperatures between 60 and 70 degrees C. Again, repeating, as I said earlier, when we moved from non-condensing boilers to condensing boilers, really we should have reduced that flow temperature to 60, and we didn't. And we're used to on-off heating controls, the old clunk-click controls. Even if you look at Hive or Nest, they are still on-off controls, when really we should be looking at load compensation and weather compensation as standard. So with both of those sets of controls, like weather compensation looks at the outside air temperature, it knows what temperature you want in the house, and it will adjust the flow temperature of your heating system to maintain the warmth in your house, and it will adjust it periodically. Load compensation does the same, but it looks at the return temperature, so it tries to maintain a constant return temperature, keeping the home warm and comfortable. These are standard in Europe. They are not standard in the UK, and we are having to move from a on-off, touch the radiators, and if it doesn't take your fingerprints off, then the boiler's not working, to these radiators are warm, why are they not hot, and having to go through and explain to the consumer that depending on the temperature outside, the radiators will adjust their temperature. And you get wonderful questions come back of, well, how do I dry my towels? How do I dry my washing? So these are all things that we're tackling as part of the heat pump industry, as part of training our installer base and making sure that consumers are educated when they're when and if they get a heat pump system. So we also have a range of heating systems in the UK. So the most prevalent is the combi boiler, which is a heating system, small, compact, heating and hot water from one single box on the wall. One of the great advantages of the combi boiler is it never runs out of hot water because it heats it as you need it. but we have made compromises for the combi boiler that some of us may have forgotten. Having a hot blast of too hot a water if the heating's been running. You know, if you're running the hot tap downstairs and you try to turn the shower on, you suddenly don't have enough hot water coming out of either tap or the shower. But they do a great job, and we are very space poor in the UK, so we need to be equal to that. System boilers are an upgrade to the regular or open vent boiler system. So that's a boiler with a hot water tank, a pressurized hot water tank, giving plenty of hot water and providing and then having a system boiler. So those boilers tend to be a little bit smaller because you don't need the power instantaneously to heat the hot water. And then we've got the regular or the open vent system, which is the most traditional system in the UK, normally installed where we have very low water pressure. It's where we have the water tank, the gravity tank in the loft that feeds a tank, generally in the airing cupboard, and the boiler somewhere along in the system. So a heat pump system is pretty much the same as the system boiler installation. So we have to try and convince people that they want to give up some cupboard space for a cylinder, which is going to be challenging. But there are advantages to having a cylinder, such as taking advantage of demand side response and using it as a thermal battery or a thermal store moving forward. So what system solutions are there for heat pumps? So a hybrid heat pump system solution is one. I had one of these in my own property for a while. I bolted on a 5 kilowatt heat pump to my combi boiler system. I had a buffer tank, so I had a buffer tank, a small 40-litre one, and the flow and return for the boiler went in at the top. The flow and return for the heat pump went into the bottom on the left-hand side, and on the right-hand side I had a pump, and that went off to my heating circuit. So what you're doing with this is you are using the heat pump as your primary source and effectively turning the boiler into a turbo. So the heat pump will come on and heat the system up, and if the heat pump is not big enough or there's more heat required, the boiler will come on, act as a turbo, boost the heating up, and then once the heating's up to temperature, the heat pump will then again take over and tickle the heating along, maintaining the warmth. This is a great system if there's a local grid constraint. So if there's a restriction on the local electricity supply, or for large properties where a three-phase supply may be required for a heat pump system. The downside with hybrid heat pump systems is you need to spend extra time setting up and commissioning the control and ensuring that the end user understands how to use that control. Moving forward, these could be a great answer for demand side response, as it's not beyond the realms of possibility that a third party, such as a utility provider, could send a signal to the heat pump to tell it to turn up, down, on or off, depending on how much renewable electricity there is in the grid, and the boiler could be there as a comfort. And that boiler could change to a direct electric system moving forwards. But that is just one solution that we have available to us. Then we have monoblock and split air to water heat pumps. So monoblock meaning one, so that's the complete refrigerant circuit in a single case that sits outside. These are the most popular products in the UK because you do not require any F-gas or refrigerant handling qualifications to install them. So these are very, very simple: power, communications cable, and a flow and return. And then they go off into the heating system. The other type that are very, very similar to this is a split air to water heat pump. So the split is the refrigerant circuit is split over two units. So you have the outdoor unit with the evaporator and the compressor, and then you have refrigerant pipe going to an indoor unit, which is normally the same size as a boiler. And in that boiler, in that indoor unit, you have a condenser and your water pipe work. So monoblocks are the most popular because they're plumbing skills that are required. Split air to water. These can be very, very useful if you're in an area that has a very unstable grid, or you want to put the outdoor unit far away, as there is no risk of freezing when there's refrigerant pipe running outside, where there is a risk of freezing if it's water pipe. And then we have ground or water source heat pumps. So this, instead of using the air, is using a ground collector. So you drill some pipe into the ground, you fill that with brine or antifreeze solution, which is pumped around the loop. The loop collects energy from the ground, which is generally quite stable. Once you get past 1.5 meters, the ground temperature is generally around 12 degrees C. So you pump the fluid around there. That fluid comes back. It's normally comes back to the heat pump anywhere between 0 and 5 degrees, and the heat pump then uses that as its source and boosts the heating for heating in the home and the hot water. These could be a great solution for dense housing, where you could, if you see companies like Kenza, where they have a common ground array, so they have a large ground array with individual heat pumps connected to that large ground array, reducing the cost of the infrastructure. There's no outdoor unit required, and because the ground temperature is generally pretty stable, the performance and efficiencies of the ground source heat pump are very, very stable. This could be a great solution for dense housing, where you have a common ground array and individual heat pumps feeding off of that, a bit like the gas network and gas boilers today. And then we've got heat network heat pumps, so low temperature heat network heat pumps or ambient loop heat pumps. These are another version of ground and water source heat pumps. So in this example, if you had a block of flats, you've got this energy loop in the middle. So that would be a water, and you'd maintain that energy loop anywhere between 10 and 40 degrees. And then in each apartment, you would have individual heat pumps that are using this as its source. Because this source is a higher temperature, the efficiency and the output of the heat pump would be higher, and you can use that to heat and cool the apartment in there. One of the great advantages of this is it can reduce the central plant by 60 to 70%. There's no requirement for metering and monitoring, because there isn't usable heat in the ambient loop, and you can use waste heat from industrial areas. So this is something that could develop for high dense urban areas, and have been proven to work in central London. So I've run through some of the UK homes and the different solutions that are available. So the price disparity between gas and electricity, which is a challenge for us at the moment. So this was provided to us by the European Heat Pump Association, and it shows the ratio of electricity price versus fossil fuel versus gas mainly. So the higher the ratio, lo and behold, you get the lower penetration of heat pumps. So in the UK, unfortunately, we have the highest gas electricity price ratio. So it's 4, almost 5. So a unit is 4 times the price of a unit of gas, or 4.5 times the unit price of gas. Whereas if you look at Norway and Sweden and Finland, again, those colder climates that had the higher penetration of of heat pumps, they've also got the lowest electricity costs. So the lower electricity costs see a greater penetration of heat pumps, and this is a real challenge for the UK, and it's very much a political hot potato, because our understanding is the consultation for this for decoupling the gas and electricity price has sat on a number of ministers' desks, previous government, and is now being rewritten to go to the minister for this government. But we saw the backlash from removing the winter fuel payment, so there is absolutely no way that we're going to get a consultation regarding this, which could be seen as increasing the price of gas when we're moving into a winter period. But if we want consumers and we want homes to move across to electrical based heating, the cost of electricity has to come down in relation to gas. Now, my own personal view here is we can't do that by raising the price of gas, because that will put far too many people into fuel poverty that are already struggling. We need to find a way to make sure that we're making the most of the electricity that we generate from our renewable sources, decouple the price from gas, because at the moment the gas is the highest price electricity generator, and that sets the price for the whole grid. So really we need the UK to be aiming to the same sort of price ratio as Ireland, the Netherlands and Lithuania. And the dream scenario would be we get somewhere near Finland and Sweden. But make no mistake, this is one of the main challenges that we face in the heat pump industry, or the accelerate electrification to get people off fossil fuels and to stop burning things in their homes. This is the key thing we need to switch in the UK. So where are we now in terms of the market? So HPA started collecting market figures from our members in 2022, and we went back and we collected them, so we can see a strong growth moving forward. This UK heat pump factory sales data. We can see that the UK has been sustaining steady growth. It's dominated by the air to water heat pumps, both monoblock and split, but you can see here that monoblock is way out in front. I should note that these do not include air to air heat pumps, so air conditioning or air heat pumps. These are not included. Just for useful insight, I can share with everybody today that the September sales have come through, and we've actually sold more heat pumps year to date this year than the total of last year. So we're close to we're circa 70,000 units year to date, and we're seeing a big step increase in the number of sales going out. So that's really good news. So we're about 48% up on well, over 50% up on last year now. So, but we are coming from a low base, but it's good to see that we're seeing sustained growth, particularly in the context of Europe, which has seen the market contract by about 40%. And the UK boiler market year to date is actually down by 13.5%. So the heat pump market is doing very, very well in a challenging heating market. So one of the key points that we've got, and something that I've alluded to, is we're moving our heating systems across, and as such we need to train and retrain the installer base. So as you can see from this year, that the number of people going through the training course is increased exponentially. We're waiting for I'm waiting for confirmation on on Q3 results, but I'm being led to believe that we trained around 2,500 and 2,500 more heat pump installers in Q3. So we're seeing great growth in that. It is being supported by the government with a training grant, and we are making sure that training is just the first step, but we're trying to follow up with more further research to make sure that those trained individuals then go on to install a heat pump. So we've seen 166% increase from 2022 to 2023, and we're working behind the scenes to elevate the total heat pump workforce needed to meet the 600,000 heat pump target by 2028. And hopefully we'll be able to share more information of that moving forward. Okay, so heat pumps supported by a government scheme. I thought this one could be interesting for everybody. So in terms of determining what is driving the growth, the graph on the screen shows how many heat pumps each government scheme which provides heat pumps with funding and support on a monthly basis. So as you can see, this is dominated by ECO. So ECO is the energy company obligation. So this is the green levies on our electricity bills are put towards home improvements, and you can see that a large number of those are installing heat pumps now. And the boiler upgrade scheme, or the BUS, which is the £7,500 voucher a private homeowner can get for installing a heat pump in their home. So we have each supporting over 1,000 heat pumps installations a month since November 24. Coinciding with the BUS grant increase. The red line over the top of the graph shows the total MCS registered heat pump installations on the database, which we expect to be higher due to the heat pumps in the new build. MCS advise around 15% of heat pump installations notified are within the new build market, and they don't get any government support. Installations in Scotland under the Home Energy Scheme and grant, and those able to pay don't require grant funding. I should point out here that this graph represents a proportion of the market and doesn't paint a full picture, but does give you useful indication on what's driving interest and readily available readily available data. Based on our analysis, we would suggest that MCS registered installs are consistently around 60% of total heat pump sales, which includes some heat pumps which would fall out of the scope of MCS due to size. So the government schemes are really starting to take traction after a slow start. Again, limited to MCS registered installations, but this graph clearly shows the scale and the speed of the growth witnessed in the sector for the past 4 years, with 2024 looking like it's going to be a record year for heat pumps, which, judging by September's sales, it really is. So the future looks bright for heat pumps and low carbon heating. We have the future home standards coming in, which means that this effectively rules out gas-fired central heating in new build systems, as they don't meet the emissions or the efficiency standards required. Labour have announced a upgrade 1 million homes to cut bills. So that's going to be a mix of insulation and heat pumps and upgrading heating systems. There's changes to the permitted development rights. So at the moment, there's a limit on the physical size of a heat pump that you're allowed to install without planning permission, and that's being removed. There's also a constraint that heat pumps need to be 1.5 meters away from the boundary, which is being removed as well. Phasing out of installation of fossil fuel heating in homes off the gas grid. So that we're waiting for a bit of clarity on that. We're waiting for the consultation to come back, but that is looking at LPG and oil boilers. And, you know, are they going to move to bio LPG and bio oil? How do you make sure that if somebody goes and buys a tank of bio LPG this quarter, they don't go and buy a standard bottle of LPG the following quarter? And the new minister, who is being very active and has been putting us through our paces and asking questions. So we've had no official policy announcements to support the accelerated development of heat pumps, but recent answers to written questions make it clear that heat pumps will still play a pivotal role in the decarbonisation of home heating. Expected technical development. So something that's been important, delivering a smart and secure electrical system. So any electrical based heating system has the potential to be a smart energy asset. In order for it to be a smart energy asset, it needs to be secure. And when we say smart, what do we mean by smart? So there's the SSES work that's going on at the moment, and we're looking at how we can develop a smart, secure energy system, and what role low carbon and electrical based heating can play on that. So as I mentioned earlier, could that be a utility sending a signal to your system to turn on and overheat your house? So maybe turn your heating on at 3 o'clock, 4 o'clock, and then when you get home at 5 o'clock, the house is nice and warm, but the heat generator isn't actually on, and it doesn't need to come on until 7 o'clock because the house will hold on and retain that heat. There's lots of living lab assessments on that type of thing going on as we speak, and you know the tariffs that you've seen from Octopus and OVO and EDF more recently are all in line with that. We've also got the F-gas phase down, which I'll go into on a little bit more detail, but the gases that are used in heat pumps are changing, relating to the global warming potential. So we did have a gas called R410A, which was standard for everybody, but that has a GWP, or global warming potential, of 2088. So what that means is for every ton of R410A that leaks into the atmosphere, it's the equivalent of 2088 tons of CO2. So with carbon emissions being a key focus, there's a phase down globally of high GWP refrigerants, and we're looking, so all of the heat pumps are moving away from high GWP refrigerants to other lower GWP refrigerants. And the home energy modelling, which is linked to the Future Home Standard. So at the moment we have SAP, or the Standard Assessment Process, which gives you your A, B, C, D, E rating for your home. That is being changed from a standard assessment process to a home energy model, which is going to be more sophisticated and hopefully give better examples, and will look at whole life emissions and in-use emissions as part of the design standard, which is one of the reasons that fossil fueled heating will not be eligible in future new builds. So looking at the F-gas phase down, we're kind of we're here at the moment, and we're going through a consultation period because we're still part of the EU when it comes to this, and the EU are looking at phasing down GWP refrigerants, high GWP refrigerants, even quicker, which is going to be a challenge for the industry. So at this stage when R410A was prevalent, to give you some idea of how that impacted the market, R410A was trading at about €6 a kilo at this point. When we got this drop, it dropped to €46 a kilo. So the cost of it went up exponentially, and now we're looking at different refrigerants as we phase down. So you'll notice that if any of you are keeping an eye, lots of people are launching R290 heat pumps at the moment, which is propane, which has a GWP of 3. The challenge that we have with propane is it's flammable. So we need to take the learnings from our gas colleagues and ACS and make sure that we've got the suitable safety requirements in place to make sure that we're not putting any undue risk on anybody when it comes to using flammable gas. But you know, for me, it seems a lot safer, because instead of having a flame in a box in my house that's connected to a high pressure pipe with terawatts of gas in it, I've got a unit that's outside with 600 to 1.2 kilograms of a flammable gas, and there's no flame in the unit. So it seems inherently safer to me, but I would say that, wouldn't I? So with the new government brings challenges and opportunities, excuse me. So I've gone through where the market stands now, but of course we've got to look with interest to the future. What is the government intent? So we've got our first budget next week. We've also been informed by colleagues at DESNZ that the 11th of November is going to be a day for heat pump announcements. So we're looking forward to see what that brings. But we have a new government which presented us with both an opportunity and a challenge. There's no doubt that the policy will be a core driver in accelerating the deployment of heat pumps. Labour's manifesto focused on delivering 5 missions. Whilst energy was one of the core missions, GB Energy has been the focus on greening the electricity supply and generation, and not specifically decarbonising homes. Whilst the manifesto noted the warm homes plan, we're still in a little bit of wait for detail, but hopefully we're going to get that in the very near future. So just a reminder on the key points, really. The challenges that we face in the UK and the opportunities are reducing the electricity and gas price differential. So it's a towards pleasure towards pleasure choice rather than an away from pain. We need different solutions for different property types, which the manufacturing team and the manufacturers are stepping up to, looking at developing different heating solutions for different property types to make sure that they fit. And heating system design is crucial to lifelong performance. So designing in efficiency at the start, so making sure that we've got a strong installer base that can fit and design efficient heating systems. Thank you. Any questions? Sorry about the coughing in the middle of that.